Okay, we have a question over here. It says, if x, y, and z are integers, all right, so this is a given to me. It goes on and says it satisfies this equation over here. Right, it satisfies that. List all possibilities for the ordered triple. That's x, y, z. I do notice a footnote over there. The footnote's 131. All right, what does it say? Again, that's Stanford math tournament. Right, it's from 2012. I'm sorry. I'll look at this thing. I would say the first thing I would do. Well, let me go to the whiteboard first off. And in the whiteboard, write down. Again, I'll write the problem down again, which I would not do if I was on an exam, by the way. So I'm certainly looking at it. X, Y, Z plus 4. And then you get x plus y plus z. But I know that x, y, and z, looking back over it, are integer numbers, all right? They're from the integers. I know that much. And then this is going to be 2 xy plus xz plus yz plus 7. Let me see if I copied it right. Xyz, 4 times x plus y plus z equals 2 xy, xz, yz, 7. And they want me to list all the triples. So they're going to be like x, y, and z. Now granted, I would look at this thing, my first kind of impression about it here is that I would like to get the variables on one side, the constant term on the other side. So write this down, x, y, z plus 4, let's see, x plus y plus z minus 2 xy plus xz plus yz, and that would equal the number 7. Now my next goal over here, believe it or not, is to try to factor the thing, and it looks somewhat like it might be factorable. And I'm going to rearrange it a little bit, and I'll write this over here. So I'm going to write down x, y, z. It sort of looks like it's almost binomial in form, but anyway, let's keep going through it. So x, y, z, I'm going to say minus 2 xy xz plus yz. It's always tough doing this, by the way. And the 4, I'm going to actually write as 2 squared. That's going to be 2 squared, and x plus y plus z. Here comes the tough part. There's a missing term there for that to factor out. And I'm going to say, plus minus minus. And then I'm going to say, 2 none, 2 1, 2 2. Looks like 2 3. Put that over there. Now here's the problem. If I subtract 2 3 from the left side, I got to subtract 2 3 from the right side. When I say 2 cubed, I should say, not 2 3. All right. Now the question is, it sure does look, binomial in form, and I'll say what it looks like to me. It looks like x minus 2, y minus 2, and z minus 2 equals, well, 7 minus 2 cubed is going to be minus 1. And this is my goal at this point. By the way, I want to point out, I do get x, y, z. I do get that. I do get this over here. And then I get those combinations in the middle, by the way. All right? And again, you may want to multiply that to make sure that's the case, by the way. So then I'm looking at this thing over here, and I'm wondering how I can make that 1. And there's a possibility for that. I'm sorry, minus 1. I could have minus 1, minus 1, minus 1. That would equal minus 1. What else could I have? I could have, let's be careful about this, ladies. So it's a minus 1, minus 1, minus 1. I could have minus 1, and then a 1 times 1. That also equals minus 1. I could have 1, minus 1, and a 1. That gives me minus 1, all right? I could have, let's take a look at that. I could have, let's see, 1, 1, minus 1 equals minus 1. Is there another possibility? There's no other possibility, by the way. So I'm going to start to write down, how to get this. And let me just make sure. I'm going to be putting triples down now. One at a time, right? There's going to be 4 answers now. So for the first one, I'm going to say, I'm looking at this one now. I'm going to say 1, 1, 1. This one's done. Let's put the next one down. Let's say I want minus 1, right? So it's still going to be 1, and this would be 3, and this would be 3. I'm doing the x, y, z, by the way. This one's done. Let's do the next one. What do you get there? You get 3, you get 1, and you get 3. Let me make sure that's true. 3 would give you the 1 would give you minus, yeah, looks pretty good. Let's put the next one down. What do you get there? Let's see, if I want 1, I get 3. I get 3 again. And to get the minus 1 there, I'd have the 1 over here. And these are my 4 solutions to the problem, by the way. And we are now done. Thank you.